Hello students, welcome to my video lecture. Today I am going to give a video lecture on chemistry practicals, paper 2. My topic is determination of density and viscosity of a given organic liquid. Now in your examination, you are going to take an examination for 35 marks, total marks. Now this determination of density and viscosity carries 20 marks, and you are going to have a viva of carrying 5 marks, and then a record carries another 5 marks. Total you are going to be evaluated for 35 marks. Hence, please pay attention when I am explaining the class such that you can answer the viva very well. So let's get started. How we determine density. Later I will be showing you that we use a density bottle. First I will be taking the mass of the density bottle, which is m1 grams. When I do it, I will fill in the gaps. I am going to fill the liquid in that bottle. Determine the mass that corresponds to m2 grams. I later empty that organic liquid, fill it up with little bit of acetone, wash it well, wash it with water thoroughly, and then fill water and determine the mass that corresponds to m3 grams. Now, mass of liquid, you know very well that m2 minus m1 gives you mass of liquid. Mass of water is your m3 minus m1 grams. Now, let me do that experiment and show you. This is the bottle. You can see that it has a lid. Not only a lid, there is a small hole in it, and actually the liquid can come up to that top due to the capillary action. Now let me take the initial mass, place it on the thing, note down the mass, which is 21.80 grams. Now into this liquid, I am going to fill the organic liquid for which I need to determine density. I will conveniently fill it up to the brim. It is filled up to the brim. Now I am going to place this nozzle on the top. Naturally, the excess liquid falls, and there is a lot of liquid sticking on, which I need to wipe it clean. So I wipe it well here. The bottle. Ensure that all the liquid is wiped neatly. Now I don't wipe it for a longer period on the top. I take a quick wipe like that, such that if I hold the paper for a longer period, the liquid is going to get sucked into the paper. Now this is ready. I will place it on the balance. Take down my second mass, that is 45.65 grams. You are not going to waste this liquid. Pour it back. Now since this is an organic liquid, I take a little bit of acetone. Ensure that all the liquid is well washed because acetone can remove the organic liquids very well. I'll pour back the acetone. Now wash my bottle well with water because now I am going to fill water. So it's important that my density bottle is very dry when I take the first weight. If there is water or moisture, then it will give rise to a lot of error. That is the reason we take the mass of water in the end. Now I have to ensure that I have washed it well with water. Even the nozzle portion needs to be washed well. Throw the water out. Another rinse. Now I shall fill this with water. And place the lid as before. The excess of water falls. The water is there in this nozzle too. Wipe it clean. Ensure that all the water is dried thoroughly. The more of accuracy you take, the better results will be got. So now wipe this portion also. Now when I am wiping on the top, I take a quick wipe such that the liquid is not sucked into the paper. Okay, now I'll keep it on the pan. Get my third mass, that is with water, 49.5 grams. Now why are we filling it with water? This is because we do relative density. We are determining mass of liquid, then mass of water. We are having the same experimental conditions because into the same bottle only you have to fill the liquid. That is the reason we actually first find out a relative density and later determine density of the liquid. Now let me do the calculation part. Throw the water and we are done with this density part. Let me do the calculation and later explain it. Now I am just going to fill in the values that we took. Mass of empty density bottle is 21.80 grams. That with liquid was 45.65 grams. And with water it was 49.45 grams. Now today's temperature is 28 degrees centigrade. From this chart I determine what is the density of water, which is 0.9962 into 10 to the power 3 kg per meter cube. Why do we use this kg per meter cube? This is because it is the SI unit. Now let me just recap how we did density. Density is mass upon volume. Now mass is in terms of kilograms. Volume is meter cube. Now since I have weighed in grams, I am going to divide my weight of grams divided by 1000 such that it is converted into kilograms. Coming to the volume, I have meter into meter into meter, that is meter cube. 1 meter is nothing but 10 to the power minus 2 centimeter. Since I have taken in grams and it is in cubic centimeters, I need to convert it into SI unit. Therefore, when I multiply it 3 times, it becomes 10 to the power minus 6 meter cube. So, below I have volume 10 to the power minus 6 meter cube. So now I take the mass of the liquid, that is difference in mass. I subtract 45.65 minus 21.80. I get this value as 23.85 grams. Then I determine what is the mass of water, which is 49.5 minus of this, which comes to 27.85 grams. Okay. Now, what is relative density? Actually, density is mass upon volume. I need to determine what is the capacity of that density bottle, which is going to be difficult. Therefore, I do for liquid and then for water. So my relative density is density of liquid divided by density of water. Since I have taken in the same bottle, the volume terms get cancelled, which is nothing but mass of liquid divided by mass of water. I transpose this onto the other side and multiply it by density of water. Therefore, I have here value 23.85 divided by 27.85 into mass of water, which is 0.9962. Now you know what is the unit I should be using. Now I have kilograms on the top, 10 to the power 3 into 10 to the power minus 6 makes it 10 to the power minus 3 at the denominator. So when I take it to the numerator, here I have 10 to the power 3. So whatever I value, I multiply by 10 to the power 3 kg per meter cube, or when I take meter cube onto the top, it becomes 10 to the power minus 3. So that's the reason. Whatever values you get in grams, substitute it and multiply it by the mass of density of water, which is directly given as 10 to the power 3 kg per meter cube. When I do this calculation, I get a value of 0.8533 into 10 to the power 3 kilogram per meter cube, or I can write so much kilogram meter to the power minus 3. Both can be done. So I hope you all understood how I determine density. I just first take the mass of empty bottle first because it's very dry. Then I fill liquid, determine its mass, fill water and determine the mass. I just do simple arithmetic of this. What is relative density is density of liquid divided by density of water. And ultimately, how do we get density of liquid? Because we transpose the density of water onto the other side. So always you have been provided by this value, that is density of water. So this part 2, that is determination of viscosity. We use this apparatus which is called as the Oswald's viscometer. How do we define our viscosity? Viscosity is defined as the resistance that is offered to the flow of liquid. You know that when I take a liquid in a big nozzle of this size, the liquid is adhered to the walls, that will have a different flow. The liquid that is there in the middle will have a different flow. Hence, in this Oswald's viscometer, there is a fine capillary here through which the liquid flows. So I make the liquid flow through this liquid, the fine capillary, and determine what is the time of flow. So greater the thickness of the liquid, that is, if it is more viscous, then it will rather flow slowly, and also it depends on what are the intermolecular force of attraction, everything, and otherwise it will flow fast. So since I am here, as I did relative density, I will be doing relative viscosity, and I am finding out viscosity of my liquid as force per unit area, that is the resistance offered by the liquid for the flow as a function of time. Hence, my unit for viscosity is my force, which is Newton. Unit area is per meter square multiplied by time factor, that is the time it takes for the flow of liquid. Therefore, it is Newton per meter square into second. That is the unit of viscosity. Now, how am I going to do? I am going to clamp this viscometer onto this here. Take 10 ml of my liquid for which I need to do viscosity. Pour it through this knob. Use this other end. Fit it with a rubber tubing. Okay, and then suck the liquid to a height of this side, and I can see that there is a fine marking here and there is another marking here. Therefore, I am going to find out using the stop clock what is the time it takes for flowing from here to here. So since I need to repeat this experiment, repeating this experiment is very simple, because every time the same thing, I have to suck the liquid and make it flow from here to here and determine what is the time of flow in seconds. So let me do this. So I have taken 10 ml of the liquid